Let us discuss the key properties of greatest integer function one by one. First of all, this is the notation for the greatest integer function, and you know the definition of greatest integer function. I am just revising it. Greatest integer function takes the real number as input and returns the output as immediate lower integer. So what happens to that lower integer? That immediate lower integer is generally greatest among all the possible lower integers than the given real number as the input. Okay, this is the theory behind the greatest integer function. Now we will discuss the property one by one. First property is called definition property, means it comes from the definition. What does it say? Greatest integer function of x will be equal to n if x is greater or equal to n and less than n plus 1, where n is integer and x is real number. So understand this by example. Number 1 is 4.3. 4.3 is lying between greater or equal to 4 and less than 5. So immediate lower integer is 4. So answer is 4. Similarly, minus 7.4. Minus 7.4 greater or equal to minus 8 and less than minus 7. So this is the interval in which minus 7.4 lies. What is its greatest integer which is lower than this? That is minus 8 immediately. Otherwise minus 9, minus 10, that is also lower than minus 7.4. But among all those set of integers, minus 8 is the immediately lower number, lower integer than the minus 7.4. So this is the value for minus 7.4 greatest integer function, minus 8. Okay, so comes from the definition only. Now comes to the second property, fundamental inequality. This says that this x value, which is the real number, okay, it will always lie between the greatest integer function of x, means x will be greater or equal to greatest integer function of x and less than greatest integer function of x plus 1. So let us understand by the example. Suppose I have this inequality 9 greater or equal to a greatest integer function of 9.6 less than 9.6 greatest integer function plus 1. So let us see whether this is true or not. This will give you 9 immediate lower integer. This is no change. This is 9 plus 1, that is 10. So now you can see that this inequality is holding true. So this is the meaning of this fundamental inequality. One more example with negative sign. Minus 7.9 is greater or equal to greatest integer function of minus 7.9 and less than minus 7.9 greatest integer function plus 1. So let us see. Its value is minus 8 less equal to minus 7.9. Its value is minus 8 plus 1, that is minus 7. So now you can see that this inequality again holds true, that minus 7.9 is less than minus 7 and minus 7.9 is greater or equal to minus 8. True. So this is the fundamental inequality meaning. Now come to the third property, integer addition or extraction. Means suppose you have x plus n, means x is real number, n is integer. In that case, the greatest integer function will give you greatest integer function of x and n will come out as it is no change, because integer value there is no change. Okay, so understand by the example 3.2 plus 4. Now when you will add, it will give you 7.2. 7.2 greatest integer value is 7. Come to here, if you separate it, 3.2 plus 4, so 3.2 give you 3, 3 plus 4 will give you 7. So 7, 7, same. Similarly, I have given the another example, negative numbers, minus 4.7 plus minus 3. So when you will simply add, so minus 4.7 plus minus minus 3, so minus 7.7. Minus 7.7 will give you minus 8. Okay. Now come to this side. Minus 4.7 plus minus 3 will come out as it is. So minus 4.7, its value is minus 5 now. Immediately lower integer, minus 5. So minus 5 plus minus 3, that is minus 8. So you can see left hand side and right hand side are same. So this is the meaning of integer addition or extraction. Now come to the next property, value of integer. That is greatest function of integer, there will be no change, as it is it comes out. If it is positive, it will come out as positive number. If it is negative, it will come out as a negative. Now, in case of negative input property, means when we enter the negative real number, then what happens? Because in case of integers, minus x greatest integer function will be minus and greatest integer function of x. So basically there is no change in that value. But in case of real numbers, what happens? Minus x greatest integer function, it will give you as minus of greatest integer function of x minus 1, means 1 less than the given greatest integer function value in case of real number. In case of integers, there is no change, there will be no change, only sign, same sign you will take out as a greatest integer function value. Example, minus x will come out as minus greatest integer function of 6, that is minus 6, but minus 6.5. So first of all, take the minus sign out, then greatest integer function of 6.5 and minus 1. So 6.5 is immediate lower integer is 6 with minus sign. So minus 6 minus 1, that is minus 7. Now you already gone through this situation that minus 6.5 greatest integer value immediate lower integer, that is minus 7. This is theory behind that. Okay. Now come to the 6 inequality property. If greatest integer function of x greater equal to n, then x will be greater equal to n. So let us understand 4.8 greatest integer function which is greater equal to 4. So 4.8 without the greatest integer means only the number 4.8 will be greater equal to 4. Okay. So this property you have understood. Now come to this. If x is greatest integer function of x is greater than n, then x value will be greater equal to n plus 1. This you have to understand. Suppose 4.8 greatest integer function is greater than 3. So its value is 4, 4 greater than 3, no problem. Now 4.8, what will be its condition? 4.8 will be greater than or equal to 3 plus 1. So 4.8 will be greater equal to 4 also. Okay, this is the meaning. Similarly here for 5.9 greatest integer function greater than 4 because its value is 5, 5 greater than 4, no problem. 5.9 will be greater equal to 4 plus 1, that is 5 also. Okay, this is the meaning. Third property, greatest integer function of x less equal to n, then x will be less than n plus 1. Let us see. Greatest integer function of 4.1 less equal to 4. Now its value is greatest integer function of 4.1 is 4, 4 less than equal to 4, no problem. Now 4.1 will be less than 4 plus 1 according to this, because if you write, you don't add by plus 1, then 4.1 less than 4 doesn't hold true. Yes or no? For that reason, 4.1 less than 4 plus 1, that is less than 5. This is the meaning of this property. Now come to the next property. If greatest integer function of x is less than n, then x will be less than n. See this? Suppose 6.2 greatest integer function less than 7, means 6 is less than 7. This will imply that 6.2 is less than 7. So understood? This is this. Now come to this property. Greatest integer function of x plus y greater equal to greatest integer function of x plus greatest integer function of y, means separately. Okay. So this together will be greater equal to separate addition. Understand by the example 2.3 plus 4.4. So if you add together, this will give you 6.7. So its greatest integer value is 6. If we add it separately, 2.3 and 4.4 greatest integer function. This is 2, this is 4, 6. Same. Similarly, another example 2.6 plus 4.4. We add it together 7.0, so 7. Separately 2.6 plus 4.4. This gives you 2, this is 4. So 6. Now you are able to see that 7 is greater equal to 6. So I have told you both cases, equal to also and greater than also. Now come to the next problem. Non-decreasing. If x1 is less equal to x2, then greatest integer function of x1 will be less equal to greatest integer function of x2. Very clear. 7.5 less equal to 8.3 suppose. Then greatest integer function of 7.5 less equal to greatest integer function of 8.3 because its value will be 7, its value is 8, so 7 is less equal to 8. True. Now the next property is fractional part relationship. This is nothing but fractional function also known as that x, any real number can be written as greatest integer function of x plus fractional part of x. Suppose you understand, suppose 7.2 is a number. We can write 7 plus 0.2. 7 is the greatest integer value of 7.2 and 0.2 is the fractional part of the 7.2. Here fractional part of x is the fractional part and it is always greater equal to 0 or less than 1. Okay, you have to understand that fractional part is always lying between 0 and 1 and its minimum value is 0. Example 8.3 that I have explained you. 8.3 greatest function of 8.3 plus fractional part of that function is 0.3. So 8 plus 0.3, 8.3, like that. Now another property, x plus y greatest integer function can also be written as greatest integer function of x and greatest integer function of y plus x minus greatest integer function of x. Okay, so this can be written as like this also. It will be helpful in the solving the problems in IIT types that I will explain you later. You can also write this as greatest integer function of x plus y plus this is fractional part of x. Okay, because see here in before x is minus greatest function of x will give you fractional part. Okay, so in the another way you can write it like this also. One more property, x greatest function of x plus 1 by n plus x plus 2 by n plus dash 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 x plus n minus 1 by n will give you greatest integer function of n into x. Why? You can understand like this. Greatest function of x and this is the fractional part. So this will also give you greatest integer function of x only. This will also give you greatest function of x only. This is fractional part, so it will be, there is no fractional part in the greatest integer function as output. So everything give you x, x, x up to n times x. So that is the nx times of greatest integer function of nx. Similarly, for any real number x belongs to R, we have x can be written as x by 2 greatest integer function plus x plus 1 by 2 greatest integer function. How does it happen? You understand. This is x by 2. This is x by 2 plus half. Yes or no? So it will come out as x by 2 greatest integer function plus half as the out of greatest integer function. So x by 2 plus x by 2 will give you x. So for that reason, thank you.